Hello, friends. Welcome to the channel. Let's get cracking with LeetCode problem number 20, valid parenthesis. Let's look at the problem statement. We're given a string S containing the characters opening brackets and closing brackets for opening round brackets, opening curly brackets, and square brackets. And the ask is for us to determine if the input string is valid. The validity of the input string is determined on the basis of these three rules. One, your opening brackets must be closed by the same type of bracket. So if it's a opening square bracket, it should be closed with closing square bracket. Open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Let's look at some of the examples. In the first example, it's a valid string because you've got a pair of opening and closing round brackets. Likewise, example two, where you've got valid pairs of all the three different brackets. Example three is an invalid string because your opening opening bracket is round bracket, but your closing bracket is a square one. And example four is a valid string because you've got a matching pair of brackets. In the last example, you have an invalid pair as the square bracket does not match with the closing round bracket. Hence, you would be returning false. Let's look at a couple of approaches. A brute force approach to begin with. What we can do is you detect and remove the individual pairs. So you detect and remove a pair of square brackets. And let's take an example where you've got three pairs of nested brackets. So you detect and remove the square bracket, and you're now left with a pair of round brackets and curly brackets. You detect and remove the curly brackets now. You're now left with just the round brackets, and you detect and remove the round brackets. And you're left with an empty string. So if you're eventually able to remove all the pairs, it essentially means that you've got a balanced string. So it's a valid pair. Let's look at another example where you have an invalid pair at the center. When you try to detect and remove a pair, it'll notice that there is an invalid pair, and the process simply stops there. So your final outcome is that it's an invalid or an unbalanced string. Let's dive into the code. It's a simple while loop where while I have any one of the pairs in the string, I will keep reducing it an to an empty string in S or replace your square brackets with an empty string, then replace your curly bracket with an empty string and return not S. Yep, let's go ahead and run the code. That's all your test cases have passed. Now, in terms of the time complexity of the solution, it's O of n squared in the worst case, because in the first pass, we're essentially trying to find all of the pairs. And in an attempt to find all the pairs, we're going to end up doing n squared comparisons in the worst case. And your space complexity is O of n because of the number of string copies that we end up doing with the replace operation. So, not the most optimal. Let's look at another approach, which is the optimal approach. Yeah. So the other alternative is to use a stack and we keep pushing all the open brackets onto the stack. When you encounter a closing bracket, what we would essentially do is we pull out the topmost element and see if it is a matching opening bracket. If it matches, we continue. We pull out, we look at the next string and pull out the topmost element, see if it's the corresponding opening bracket. And if at the end of it your stack is empty, it essentially means that you have a valid string. So in this example, you would first push the opening bracket, you would push the curly braces, the opening curly braces, and you would push the square bracket. Now, when you encounter the closing bracket, the closing square bracket, you would pop the topmost element, which is an opening square bracket, and it matches the pair. So you continue with the next character. When you encounter a closing curly braces, you would pop the last element from the stack, which is the opening curly braces. Again, you found a match. And finally, for the last character, when you pop the last element, you've got a match and your stack is empty. So we return that it's a valid string. If, however, you have an invalid string, let's just walk through this example where for the opening bracket, it gets pushed onto the stack. Opening curly bracket, it gets pushed onto the stack. Opening square bracket also gets pushed. Now, when we encounter the closing curly bracket, we pop the last element from the stack, which is a opening square bracket, which is not a match. Hence, the process fails and we return that it's an invalid string. In terms of the time complexity for the solution, it's O of n, where n is the length of the string. And the space complexity is O of n in the worst case, where all the characters are opening brackets. Let us dive into the code. So I'm going to take a stack object. Let me create a mapping of all my closing brackets to the opening brackets. So I have my closed curly bracket and my closed square bracket matching my open square. For char in is if char in mapping, if your stack is not empty or the topmost element of the stack does not match the mapping of that character, you return false. Else, I'm going to pop the last element. Else, if it's an opening bracket, I'm going to push it onto the stack and return not stuck. Yep, let's go ahead and execute that code. Right, all the test cases have passed. Let me go ahead and submit. And that's runtime of 0 milliseconds. With that win in the bag, keep stacking, keep cracking until next time. Thank you.